There is one creature remembered in the legends of almost every human culture that's ever existed. A creature depicted with remarkable similarity by the Chinese, the Aztecs, even the Inuit, who live in a frozen land where no reptiles are found. Even they have stories of this animal, the dragon. Cultures from different continents, people who had no contact with one another, yet all of them have stories describing the same mythical animal. Could it be these stories were more than myth? What if we discovered that this creature that haunts our imagination had once been real? If dragons were real, then what were they really like? How did they fly and how did they breathe fire? Why did they die out? To unlock these secrets, we'd need to find physical evidence, evidence revealed by the slow retreat of a melting glacier. What if we found a body? The Carpathian Mountains of northeastern Romania, a remote place, the last stronghold of Europe's great predators, wolves, bears, and lynx. And according to legend, here is where another great predator made its last stand, a legend that has found new life. Alpine skiers who ventured into these mountains stumbled upon a network of ice caves opened by an unseasonably warm winter. What they found inside required official investigation. A brutal medieval crime scene. The remains of human bodies dressed in 15th century armor. Men entombed in a mountain cave. And in the last chamber lay the creature that had sealed their fate over 500 years ago. A dragon carcass, completely intact, perfectly preserved for centuries in glacial ice, carefully excavated for scientific study. If the legends were in fact true, then it was fated that some form of physical proof would eventually be found. With this discovery, scientists can finally uncover the true nature of dragons. And with this find, other clues suggesting the origins of dragons might now be illuminated. The fossil remains of a Tyrannosaurus rex, the king of dinosaurs, the crown of its skull scarred by what look like talon marks. An impact injury sustained from above. Here are the telltale signs of an ancient species of dragon that lived millions of years before the creature found in the glacier. The Cretaceous period. An age long past. When giants walked the earth. When the greatest predator ever known left its footprint on history. A period ruled by Tyrannosaurus rex. Or so we thought. Normally a stranger to this remote place. The T-Rex has been forced from his usual hunting ground. Something has been raiding his territory and food has grown scarce. He has stumbled on the lair of the most astonishing carnivore that ever lived. The prehistoric dragon. And now this dragon is in real danger. Dwarfed by the gigantic T-Rex, it attempts a bluff, extending its wings to give the appearance that it is much larger than it really is. But the ravenous Rex is an experienced hunter. He isn't fooled. So the dragon tries another strategy. A piercing shriek that briefly stuns the dinosaur. The cry carries for miles. Still, the Rex refuses to yield. And there's nowhere to hide. But the dragon still has one trick left to play. And here she comes. This is her territory, and she's defending her son. The Tyrannosaurus will not last the night. Fire is the dragon's weapon of last resort. But she delivered the final blow too late. With a broken wing, she can no longer hunt, and she can no longer feed herself or her offspring. The injury his mother sustained in the fight with the T-Rex has proved fatal. Infection and blood loss have finally taken their toll. After 2 days, her smell is already starting to attract scavengers. For the moment, they're just pterosaurs, but who knows what other creatures may pick up the scent. The young dragon lingers by his mother's body. At 6 years, his wing musculature is fully developed, but untested. Young dragons learn to fly when their mothers push them out on their own, but it's usually not as sudden as this. Our young dragon has lost his mother at a critical moment. He may never get off the ground. If he is to survive, he must discover the power of flight on his own. How did dragons get aloft? A look inside this dragon's body will reveal the most ingenious adaptation in the natural history of flight. A system that remained largely unchanged for millions of years, from the early prehistoric dragon to this species found in the ice, the mountain dragon of Western myth and legend. The initial analysis of this dragon shows other adaptations for flight besides the obvious wings. The chest points towards a clear function. It's powerful, heavily muscled, similar to what one would see on birds of prey like falcons and eagles. Preliminary internal scans of the body are more revealing. A massive heart, also indicative of powered flight. The chest muscles would need large quantities of oxygen-rich blood to maintain a steady wing beat. The bones are perfectly designed for flight too. The internal structure is very specialized. It's honeycombed, a skeletal design also found in birds, strong but very lightweight. All of these adaptations are general characteristics of powered flight. But this creature still looks too heavy to be supported by such relatively small wings. They couldn't possibly generate the kind of lift needed to get an animal this big off the ground. The wingspan measures under 20 feet, and with an initial estimated weight of 900 pounds, scientists would have to probe deeper to find the key to dragon flight. Continued scanning shows something more unusual inside the chest cavity, a pair of leathery organs resembling a second pair of lungs. The tissue walls of these organs are thin and elastic, designed to expand. They're storage sacks. What did they hold? The answer escapes with a hiss. Gas. Not gas from decomposition, the specimen is too well preserved. This gas was present while the animal was still alive. But what is it? Analysis proves the gas is composed predominantly of hydrogen. Hydrogen gas is 14 times less dense than air. Fill a balloon with hydrogen and it rises. Fill these organs with hydrogen and the principle is the same. These are the dragon's flight bladders. But how did dragons produce the hydrogen that got them off the ground? Getting off the ground. It's a problem confronting the young prehistoric dragon as well. Unable to hunt, he exploits the only food available to him. Even in death, his mother may still help him live. She may even still help him to fly. All creatures contain bacteria in their gut that help break down food, and in the process, the bacteria release metabolic byproducts. Gas. But the bacteria inside dragons are unique. They release hydrogen, and unlike other animals, a dragon's gas doesn't go to waste. The hydrogen is channeled into the two storage sacs, the dragon's flight bladders. Along with the super light skeleton, the gas-filled flight bladders are the keys to dragon flight. And now this young dragon's sophisticated flight system is about to be put to the test. While the pterosaurs wait their turn, a more dangerous creature has picked up the scent of his decomposing mother, an older male dragon. Its broken horns and dull appearance betray a dragon at the end of his days. Constant territorial battles mean that male dragons rarely reach old age. Few live past 40. Pushed from his territory by a younger and fitter male, this dragon is a nomad. He now wanders in search of food, scavenging other kills more often than making his own. But given the choice, he'd prefer fresh meat. And this time, the young dragon's mother isn't there to save him. The old nomad closes with surprising speed. The juvenile's only hope of survival is to get airborne. Cleverly, he heads for the trees. He knows the old male cannot fly here. Inside, his body is working overtime, his heart beating, his muscles pumping, hydrogen being generated at a prodigious rate. But it's still not enough. His flight bladders may be full, but so is his stomach. The undigested meat is weighing him down, and so instinct takes over. At the last moment, he empties his stomach and spreads his wings at last. The young dragon takes flight for the first time in his life. But if he's lived to fight another day, he will have to master another legendary evolutionary adaptation. He must learn to breathe fire. The body of a dragon, revealed in the melting ice of a glacier. What if such a discovery were made and the legends of this fantastic beast proved true? Scientists, autopsying its remains to learn how dragons could fly, would find a complex system of hydrogen gas and a super light skeletal system. But where is the physiological evidence to support the dragon's most spectacular adaptation? How did dragons breathe fire? What would this body tell us? The inner surface of the mouth is almost armor-plated. At the back of the throat, there is a fleshy valve. This flap is very similar to the false palate found in crocodile throats. Crocodiles use it to stop their lungs from flooding when grabbing prey underwater. It's a distinct adaptation, suggesting that somewhere in the dim and distant past, dragons and crocodilians might share an ancient common ancestor. But why would the dragon need a false palate? Crocodiles need a false palate to prevent water from flooding the lungs. Could dragons have used a false to prevent a backdraft of fire from scorching their lungs? Evidence of a fire-breathing creature? The idea isn't as far-fetched as it seems. The natural world is full of bizarre creatures that have the most extraordinary weapons. Tongues like spears, color and shape-shifting, lassos, even creatures that shoot liquid fire. This insect is well known to scientists. It's the bombardier beetle. When threatened, it fires out a burning liquid at a temperature of over 200 degrees Fahrenheit, almost boiling point. It does it by pumping a liquid fuel into a reaction chamber where a catalyst ignites the mixture. The burning chemicals have nowhere to go but out, and with a bang. Nature is not constrained by our lack of imagination, but it does observe rules. If dragons were to breathe fire, then they too would require a catalyst. With further examination of the carcass comes a strange find. The creature appears to have both incisors, meat-ripping teeth, and flattened molars, grinding teeth. Stingrays have similar teeth for grinding the rock-hard shells of mollusks that they feed on. But why would a meat-ripping predator like a dragon need specialized grinding teeth? Pulverized sediment is found on the surface enamel. Powdered rock with particularly large traces of platinum. Like the bombardier beetle, dragons needed a catalyst to trigger their chemical ignition. They used platinum. The reaction of platinum with hydrogen ignites the hydrogen. The hydrogen combusts. Dragons could breathe fire. Several years have passed, and the juvenile prehistoric dragon is now a young adult. He is homeless and without a territory. He will never mate. But his time has come. He has flown deep inside the territory of a dominant male. It is a daring act. Half of all young males are killed in territorial battles. The dull coat of adolescence has transformed into a vibrant display, designed to intimidate rival males and attract females. He prepares for the fight of his life. Before continuing, he stops to consume a rare and valuable mineral found in all dragon territories. Not a mineral to spark his energy. This is a mineral that will spark his fire. This is a platinum deposit. In the heart of his 100 square miles of territory, the resident dragon sends a blazing message into the air. It signals to challengers and females alike that he is fit, healthy, and confident enough to waste the precious resource of fire on a display. The message is not lost on our young male. If he has any chance at all of winning this duel, he must be at his very best. The stakes are high. With territory comes a guaranteed supply of food, and the one thing every young male needs if he is to leave his mark on the next generation. Females. And this female is the real reason he is here. She's in season, and for just 1 month will breed with the resident male. And here he is. His territory and his female are under threat, and he intends to deal with it. The resident is an experienced survivor, a dragon in his prime, and he's put down every challenger that's come before. He wears the dark coloration dominant males adopt when in command of a territory. He no longer displays the red markings of a bachelor. He now displays with fire. And his combat experience is immediately apparent. With his first shot, he inflicts serious damage on our dragon. The young dragon climbs for the clouds, desperate for cover and the cooling vapor. But the aggressive tactics of the resident aren't without risk. The very same hydrogen that keeps him airborne fuels his flame. The dragon's flight and fire apparatus is a binary system. Both rely on the stored hydrogen in the flight bladders. If the resident burns too much of his hydrogen reserves, he'll be forced from the sky. Our young dragon's luck can't hold forever. He flees for the border of the dominant male's territory. But the resident has misjudged his opponent. The young dragon isn't looking to escape. He's looking to strike. And he has a full payload of hydrogen left to burn. By using his weapons with consummate skill, he has triumphed. The female prepares to accept the new dragon overlord. The young dragon seems to revel in his victory. All his life he's fought the odds, and now at last he's come into his own. But his triumph will be short-lived. 65 million years ago, at the peak of the prehistoric dragon's success, a curtain comes crashing down on the Cretaceous period. A meteorite the size of Mount Everest careens into the planet, wiping out nearly all life on Earth. On land, nothing larger than a cat will survive, but in the sea, life will find a way. If dragons were more than just a myth, and the fact that nearly every human culture has a story about them more than just a universally strange coincidence, then a scientific explanation for them would be possible. Scientists could discover how dragons were able to fly and breathe fire. But if dragons had been alive since the time of the dinosaurs, then how did they survive long enough to be remembered by humankind? 65 million years ago, a meteorite 6 miles wide laid waste to nearly all life on Earth. The cataclysm is known as the KT event. It unleashed one of the greatest mass extinctions in the history of our planet. The age of dinosaurs was brought to a crashing halt. How did dragons escape this doom? The only other large creatures to survive the KT event all have one thing in common. They were aquatic. Sharks, skates, rays, coelacanths, turtles, and crocodiles. The dragon body found in the ice cave already suggests a common ancestry with an aquatic animal. The false palate found at the back of the dragon's throat is morphologically similar to the false palate of crocodiles. But crocodilians aren't close relatives. They branched off long before the first true dragon had evolved. But neither is this mountain dragon a very close relative of the prehistoric dragon that did battle with T-Rex. That ancient species was completely wiped out by the KT meteorite. This dragon developed along a different branch of the family tree. The descendants of the first primitive dragon followed very different evolutionary paths. At the time of the KT catastrophe, the prehistoric dragon was not alone. It had a cousin, a marine dragon. Water provided dragons with an escape route from one of the deadliest episodes in the Earth's history. Like other large creatures that endured the KT event, dragons swam from extinction. Over time, flight bladders had become swim bladders. Reduced wings developed into fins, and the powerful tail became a rudder.